Okay, so let us analyze the topic once again. I'll be recording this. I'm presenting my screen. Here, in plane geometry, we have an x-axis and a y-axis. X-axis is horizontal and y-axis is vertical. In plane geometry, if a point has both x and y coordinate positive, then it is said to be in the first quadrant. In this particular case, P, the coordinates of P is 3 and 5. That means P is in the first quadrant. Now, suppose that the x coordinate of P is negative, then it will be in the second quadrant. That means if a point has x coordinate negative and y coordinate positive, then it is said to be in the second quadrant. Now, suppose that a point whose x and y coordinates are negative, then it is said to be in the third quadrant. Now, the next case is points located in the fourth quadrant. If a point whose x coordinate is positive and y coordinate is negative, then it is said to be in the fourth quadrant. And that is for the 2D problems. Or we can say that this system is used for plane geometry. And if you consider a point located in space, this system will not be enough. Because if a point is located in the space, then we have to consider x, y, and z coordinates. In that condition, instead of this x and y axis, we have to consider the horizontal plane and vertical plane. Horizontal plane is the reference plane which is equivalent to the x-axis. In plane geometry, we have a horizontal line which is known as the x-axis. But in solid geometry or in 3D, instead of the x-axis, we have the horizontal plane, which is known as the horizontal reference plane. And in plane geometry, we have a vertical axis, which is known as the y-axis. And in solid geometry, instead of y-axis, we will be considering a vertical plane, which is known as, in short, we will name it as the VP. The horizontal plane, we can name it as SP, and the vertical plane, which is equivalent to y-axis, is known as the vertical plane, or in short, we will name it as VP. In plane geometry, the x and y axes are intersecting at a point, and we will name it as the origin. In case of origin, the x and y coordinates are 0. But in case of solid geometry, we have a horizontal plane and we have a vertical plane. These two planes, the HP and VP, are intersecting along a line. In the plane geometry, it is intersecting on a point, which we will name it as origin. But here, we have two reference planes. Instead of axis, we have planes, the horizontal plane and vertical plane. This horizontal plane and vertical plane are intersecting along a line, and this line is known as the XY line. And XY line is the equivalent of origin in plane geometry. And if you consider the 3D window, moving to the 3D window, here this is the 3D window, and in this 3D window, this pink plane can be considered as the horizontal plane, and this green plane can be considered as the vertical plane or VP. And these two planes are intersecting along a line. That line in this window, it is represented as a blue line, and we can name it as the XY line. So this is the horizontal plane, this is the vertical plane, and this blue line is the intersection, which we name it as the XY line. And just similar to the plane geometry, here also we have the quadrants. We have the first quadrant, have the second quadrant, third quadrant, and fourth quadrant. First of all, let us think about the points located in the first quadrant. You consider this red dot. Can you see this red dot? This red dot?
Yes, sir. Yes, sir.
Okay. So here, this is our point. What is the specialty of that point? That point is located above HP. So if you are looking from this side, here you are looking from this side towards the vertical plane. So what is the specialty? Here, this point is located above the horizontal plane or HP. And at the same time, you can see that this point is located in front of the vertical plane. It is above HP, and at the same time, it is located in front of the vertical plane. So, in this particular case, if you are looking from here, you can see that the point is located in front of the vertical plane. So we have a point located above SP, and it is in front of VP. And you are looking from this direction. You are looking from this direction. This is the direction. So here we have a view, and in this case the observer is facing the vertical plane. He is facing the vertical plane. Or you can see that, you can say that the observer is looking from the front of the object. Or we can say that this is the front view of the object. So this is our object, and this is our front view. So what is happening here? Here, this is our object, and we will get the projection of this object over the vertical plane. This is the object, but if you are looking from the front, then you will get a projection of that object over the vertical plane. This is our vertical plane. And if you are looking from the front, you can see that the projection of that object will be casted over the vertical plane. Like this. This is the projection. This is the object, and this is the projection of that object obtained over the vertical plane. This projection is obtained when you are looking from the front, isn't it? Any doubt in this? Any doubt in this? Okay, so here you are looking from the front. This is the actual object. If you are looking from the front, the projection of that object, you can consider that it is as a shadow. The shadow of the object will be casted over the vertical plane. If you are placing a torch towards the object from this direction, then the shadow of this object will be casted over the vertical plane. And that is obtained when you are looking from the front. So we can say that this is the front view of the object, isn't it? Because you are looking from the front. The observer is standing somewhere here and he is looking towards the object like this. So if he is standing here and looking towards the object, then he will get the projection of that object over the vertical plane. Or we can say that this is the front view of that point. Any doubt in this?
No, sir.
Okay. In engineering, the front view has a special name. In engineering, the front view is known as the elevation. Elevation. Instead of front view, we will be using a term called the elevation. So what is elevation? Elevation is the front view of an object. We are looking from the front, then you will get a view, and that is known as the elevation of an object. Have you seen the civil engineering drawings, building drawings? Have you seen that? Have you seen that? In that drawings, there will be two views, at least two views. The first one here will be the elevation. Elevation is the front view of the building. What will be the view that we will get after building that? That is the elevation, the front view. And apart from that, there will be one more view, that is the top view, or we will name it as the plan. So I will be discussing the next that concept in the next step. So now we know what is the elevation. Elevation is the projection of the object obtained when you are looking from the front. Now, suppose that instead of standing in front of the object, suppose that the observer is standing like this. It's difficult to place this 3D window here. Consider that he is looking towards, he is looking from the top and he is looking downward. So at first he was standing on the ground and looking towards the object, and the projection of the object is obtained over the vertical plane. Now, suppose that the observer is standing somewhere here. That is, he is looking from the top. He is looking downward. What will happen? The projection of this point will be obtained over the horizontal plane. This is the object, and this is the projection of the point obtained over the horizontal plane. And this projection is the top view. This is the front view, and this is the top view. This front view is also known as the elevation. Elevation is the engineering term. And for this top view, we will use another term called the plan. So what is plan? Plan is the view obtained when you are looking from the top. The projection of point obtained over the horizontal plane when the observer is looking from the top. That is the plan. So what is the difference between elevation and plan? Elevation is the front view. When the observer is looking towards the object from the front, its projection will be obtained over the vertical plane, and that projection is known as the elevation. And if the observer is positioned at the top, and suppose that he is looking from the top towards the object, then the projection of this object will be obtained over the horizontal plane, and this projection is known as the plan, or it is called the top view. So projection of object obtained when the observer is at the top is known as the plan. And if he is looking from the front, then you will get the elevation. So this point denotes the elevation, and this point denotes the plan. That is the case of a point which is located in the first quadrant. So what is the condition to be of a point to be in the first quadrant? The point should be above HP, and it should be in front of the vertical plane. If it is above HP and if it is in front of EP, then it is said to be in the first quadrant. Now, any doubt in this? Any doubt? This is our point. These are the projections of tape. This is the elevation, and this is the plan. Any doubt?
No, sir.
Okay. So we obtain the projections. Now, how will you represent, how will you draw these projections on your drawing sheet? It is not possible to draw these planes, these reference planes. Our reference planes are SP and VP. It is not possible to draw this reference planes like this, and it is not possible to show the projections over like this. For showing the projections over a drawing sheet, we have to use another technique. So now we know the projection of this point will be located here and here. This is our elevation, and this is our plan. Now, consider the horizontal plane. This is our horizontal plane. And our plan is located on the horizontal plane. Now, at the time being, the horizontal plane is positioned like this. Now, suppose that you are tilting this horizontal plane, pivoting the XY line. What is XY line? XY line is the intersection of the reference plane. Now, I am going to tilt the horizontal plane in the clockwise direction. So, here, this is the initial position, and I am tilting the horizontal plane in the clockwise direction. So, I am suppose if you are tilting the horizontal plane like this, then what will happen to the projection? The projection will also follow the plane. So, I am tilting again and again, and finally it will overlap with the vertical plane. And after that, I am looking for the front. You will get a view, isn't it? Here, this is our elevation and this is our plan. And what is this line? This blue line. This blue line is our XY line. And here, this point denotes the elevation of the point, whereas this point denotes the plan. This is the view obtained when you are looking from the front, and this is the view obtained when you are looking from the top. And these two points are in a single vertical line known as the projector. So, any doubt in that construction? Any doubt in that construction? Initially, the projections was like this. Initially, it was horizontal. This is the projection obtained over the vertical plane. This is the projection obtained over the horizontal plane. So, for representing the projections over a drawing sheet, what you have to do? You have to tilt the reference plane, that is horizontal plane, pivoting the XY axis in the clockwise direction. So, what will happen to the projection? The projection will follow the reference plane, and ultimately it will overlap with the vertical plane. And after that, you are looking from the front, so that you can see a projection. In here, this line represents the XY line, which is the intersection of X and Y. It is the intersection of the reference plane SP and VP, and the portions which are located above the XY line is our vertical plane, and below XY line is considered to be the horizontal plane, and this point is our elevation, and this point is its corresponding plan. This is the elevation, this is the plan. And what about this distance? This distance is distance of that point from the horizontal plane. This is the distance of point P from the horizontal plane. And what about this distance? This distance is the distance of point P from the vertical plane. Or we can say that this is the distance of point P from in which it is above HP, and this is the distance of point P from the vertical plane in the forward direction. This is in the upward direction and this is in the forward direction. So, if a point is located in the first quadrant, then its elevation will be above XY line and its plan will be below XY line. Is it clear? It is not that easy. This subject is not that easy. Remember that. Is it clear? This is our point. This is the projection obtained when you are looking from the front. This is the projection obtained when you are looking from the top. And these are the projections, and for representing these projections over a drawing sheet, we have to tilt the horizontal reference plane in this direction so that the projection will move along with it and ultimately it will reach here. Here, this is our elevation and this is our plan. What is plan? Plan is the top view. This is our elevation. What is elevation? Elevation is the front view. You are looking from this direction. And you have to tilt the reference plane like this to obtain the projection that can be represented over the drawing sheet. So, placing like this, and I am looking in this direction so that I will get a projection like this. This is our elevation and this is our plan. Now, if a point is located in the first quadrant, then that means it is above HP and it is in front of VP. If a point is located in the first quadrant, then in its projection, its elevation will be above XY line and its plan will be below XY line. This is our XY line, this is our elevation, and this is our plan. Is it clear?
Yes, sir.
Yes, sir.
Any doubt? If you have any doubt, please ask. It's not an easy subject. It's not an easy subject. These are the basics. These are the building blocks. Without this, you can't proceed. If you have any doubt, please clarify that. Okay, so I think all of there is no doubt. So I am stopping the